Okay, and the last option, the bee population started at 45 count. The starting point fits, but the increase by 70%. If it was an increase, it will be a multiplier of 1.7. Okay, because it's an increase, so it's going to be 1 plus 70%, which is 0.7, so 1.7 will be the multiplier. So the last option does not fit either. What about going from equation to graph, or graph to equation? Okay, so if you are given this graph, can you figure out an equation that goes with this? Well, this is obviously an exponential graph because this has the exponential shape. That means we are going to have the equation that looks like y is equal to a times b to the power of x. Okay, and so a is the initial value. That's the initial value. That means that's the y-intercept. What is the y-intercept? It's at 50. So y-intercept is 50. And what is the multiplier? What is the number that the number is about double? So it's going from 50 to 100 to 200 and to 400. What's happening to the y value each time the x is increasing by 1? It's doubling. Okay, 50 to 100 is double, 100 to 200 is double, and 200 to 400 is double. So b in this case is 2. Okay, so we know the equation is going to be 50 times 2 to the power of x. So this will be the fourth option. Okay, this question is asking you to interpret the student's work. So the first work that student does for this problem, he simplifies it, and then when he eliminates all the variable, he's just left with a number being equal to number. We have 6 is equal to 6. Well, is 6 equal to 6 always? Yeah, that's always true. 6 is always equal to 6. So since that is true, we know that all the variable has been eliminated. That means that it does not matter what the value of x is. Okay, it's always going to be true. That means that any value of x is going to be true, so we have infinite solution, infinite number of solution. What about this? In this case, the variable x has been eliminated, and we're just left with number -6 being equal to 4. That is never true. This is not true ever. Okay, so -6 is never going to be equal to 4. Therefore, we know that since the variables have been eliminated, there is a no value of x that's going to make this equation true. So therefore, it is no solution for this one. Okay, now you're going to work on some decimals practice, card number 1 to 9. Okay, you're going to be solving 2x plus 4 is equal to 10. It's asking you to show your work on the sketch pad or on your notebook, so it's up to you. If you are doing it on your notebook, then you need to take a picture of your notebook and turn it in at the end of this class. So let's solve this first. Okay, so we need 2x plus 4 is equal to 10. So how do I do that? 2x plus 4 is equal to 10. Well, what is it that I need to eliminate? Okay, so I know 2 is being multiplied to x first and then added by 4. What is it that I want to get rid of first so that I'll be left with x is equal to something? I need to get rid of 2 and 4. Which one should I be getting rid of first? We always get rid of plus and minus first. So we subtract 4 from both sides, and that leaves me with 4 minus 4 is 0, and you're just left with 2x is equal to 10 minus 4, which is 6. And then from here, I know that 2x is equal to 6. So I am going to divide both sides by 2. And that leaves me with 2x is equal to 3. Okay, so I have one solution, and the value is x is going to be equal to 3. So I'm going to erase that. X is equal to 3 and submit. Okay, next card. Very similar to the previous problem. except we have the absolute value symbol here. So instead we have absolute value of 2x plus 4 is equal to 10. So how do I solve this? Well, we know that what's inside the absolute value could be equal to positive 10 or it could be equal to negative 10. What's inside? Because when you take an absolute value of 10, it's going to give you 10 as the output, or when you take an absolute value of negative 10, it's also give 10 as the output. So we have two solutions. So we need to set that up. So we have two different equations, 2x plus 4. What's inside could be equal to the positive version, which is 10, or the 2x plus 4 could be the negative version of 10, which is negative 10. Okay, then you need to solve the equations separately. Okay, so again, 2x plus 4 is equal to 10. From here, I subtract 4 from both sides. That goes away and you're left with 2x is equal to 10 minus 4, which is 6. Then since 2 is multiplying to x, I need to undo multiplication by dividing. So x is going to be equal to 3. What about this? I'm going to be subtracting 4 from both sides. And this goes away to 0 and you are left with 2x is equal to what's 10? Negative 10 minus 4, it's negative 14. And then from here, I'm going to divide both sides by 2. And that leaves me with x is equal to negative 14 divided by 2. 14 divided by 2 is 7. Negative divided by positive is negative. So my two solutions, I got two solutions. And my two solutions are x is equal to 3 and x is equal to negative 7. And I'll submit. Alright, so then let's keep going. Now solve 4 minus 3x is equal to 10. Let's solve that. 4 minus 3x is equal to 10. So how do I solve this? Remember, when you're solving two-step equation, we add or subtract first. Okay? This 4 here is same as saying adding 4 to it. So what is opposite of adding 4? It is subtracting 4. So we are going to subtract 4 from both sides of the equal sign, and you're left with negative 3x. It's not just 3x, that negative sign belongs to 3x, is equal to 10 minus 4 is negative, it's positive 6. Okay, 10 minus 4 is 6. Then from here, I know that negative 3 is being multiplied to x, so I need to undo multiplying by negative 3. So I divide both sides by negative 3, and that leaves me with x is equal to 6 divided by 3 is 2. Positive divided by negative is negative. So x is equal to negative 2, and I just have one solution. And submit. Okay. What about this? Similar problem, except we're dealing with inequality. Well, how does that change things? 4 minus 3x is less than 10. Okay? Well, we do the same thing as if we were solving. The only difference is that with the inequality, remember the flip rule? If you ever multiply or divide both sides of the inequality by a negative number, then you need to flip the inequality symbol. Okay? So, but before we do that, what do we need to get rid of to solve for x? We need to get rid of this plus 4 first. How do I get rid of plus 4? I subtract 4 from both sides. Subtracting does not affect the inequality symbol at all. So you're just left with negative 3x, and the inequality symbol get carried down. 10 minus 4 is positive 6. Now I am going to divide both sides by negative 3. Okay, because negative 3 is being multiplied to x, so I need to undo multiply by negative 3 by dividing both sides by negative 3. When I do that, remember I need to, whenever I multiply or divide by a negative number, I need to flip the inequality. So the inequality symbol now changes, and this just simplifies to x. 6 divided by 3 is 2. Positive divided by negative is negative. So x is greater than negative 2. So here the solution is x is greater than negative 2. Okay, so it should be inequality. Now, when we're talking about inequality, how many solutions are we talking about? Well, x could be bigger than negative 2 is what it's saying. It could be, x could be a number like negative 1, it could be 0, it could be 0.5, it could be infinite many number of solutions. That's what the shading means. There are many solutions that satisfies that inequality. So there are infinitely many solutions. Alright, then what about this? Solve negative 3, absolute value of 2x plus 1 is equal to negative 9. So negative 3, absolute value of 2x plus 1 is equal to negative 9. Okay, remember when we're solving inequality or absolute value, we want to isolate our absolute value symbol before we can consider the positive and negative versions of it. Okay, we just need the absolute value on one side. We can't have, and it's okay to have anything inside the absolute value, but we cannot have anything outside. So we need to get rid of this negative 3. But to get rid of this negative 3, you need to consider what is negative 3 doing to the absolute value. This is like multiplication right there, right? So it's negative 3 is being multiplied to the absolute value of 2x plus 1. That means how do I undo multiply by negative 3? You divide by negative 3. Okay? We're not dealing with inequality, so there's no flipping or anything like that. We just get rid of that, and now you're left with absolute value of 2x plus 1 is equal to negative 9 divided by negative 3 is positive 3. Right? Negative divided by negative is positive 3. Alright, so now that we just have the absolute value on the left hand side and some number on the other side, now is the time we can consider the two different options. Okay, and when you do consider the two different options, you are dealing with the absolute value symbol. Okay, so the absolute value symbol no longer exists. So you have one equation that could be positive 3, what's inside could be positive 3, or what's inside could be negative 3. That's what we know. Okay, then you solve each of the equations separately. So you subtract 1 from both sides. You're left with 2x is equal to 3 minus 1, which is 2. Divide both sides by 2, and then x is equal to 1. What about the other? We subtract 1 from both sides. That leaves me with 2x is equal to negative 4. Divide both sides by 2, and you are left with x is equal to negative 4 divided by 2 is going to be negative 2. So my two solutions are, and I got two solutions, two separate solutions from absolute value, and I have my solutions are, could be 1 or it could be negative 2. This problem, negative 3 parenthesis 2x plus 1 is equal to negative 9. Well, we have two options. We can apply the negative 3 to each of what's inside, or we can divide both sides by negative 3. Actually, dividing both sides by negative 3 is easier, so because then you're left with 2x plus 1 is equal to negative positive 3, and then from here you are going to be subtracting 1 from both sides to get rid of this plus 1. That leaves me with 2x is equal to 2, and divide both sides by 2, and x is going to be equal to 1. So I have one solution, and x is equal to 1 is my final answer. I am going to be continuing with the next recording for the rest of the classwork.